All right, so here is the third kinematics equation for constant acceleration that I didn't write up a minute ago. Notice I did not put any vector signs on it. Like I said, the main reason is that, or really the only reason, is that you can't actually do this as a vector equation. You can't square a vector. And so what you have to do, anytime you want to apply this equation, you're going to need to go ahead and separate into x and y directions. That is, you'll need to use this only in one dimension at a time. You may not need it in both dimensions, but if, for example, you were working in the y direction and you found yourself wanting to use this equation, then you would use the y component of the velocity squared is equal to the initial y component of the velocity squared, or in other words, the y component of the initial velocity, plus 2 times the y component of the acceleration times delta y. And then likewise, if you needed to use this equation in the x direction, you would use all x components. So I just wanted to say a little aside there that for the other equations, they can be expressed fully as vectors. It's not particularly necessary to separate them unless you just want to, unless it helps you, keep track of what you're doing. However, it is necessary if you're using this third equation to use it only in one dimension at a time. And so you notice that in this case I replaced delta r with delta y or with delta x. I mean, this is the y component of delta r. This is the x component of delta r. So you could just as easily leave it as delta r sub x. But we've already been calling that just x, and we've already been calling the y position just y. So these you would use exactly like you've seen before if it were necessary to use them. It's really the other two equations that can be used in IJK notation. So just be careful of that. Now keep in mind these are still vectors in one dimension, so you still need to keep track of whether your a or your x should be negative or positive. And if you take the square root of one of these to solve, keep in mind that if you take the square root of something, you could just as easily get, say the square root of 4 could be positive 2 or negative 2. Either of those can be squared to 4. And so keep in mind that when you solve one of these equations, the answer to one of these may end up being positive or negative. So you'd still want to keep track of the left or right or the up or down for these, but you wouldn't use this equation with vectors in IJK notation. All right, now in the last video, or a couple videos depending on how long it is, we're going to take a look at one of the last big applications of everything we've done in the last few chapters.